Good morning, all of you. First of all, I am thankful to the DB College authorities for giving me such kind of an opportunity. I am going to my topic, the introduction to hypothesis testing. The presentation is in 3 different parts. First, I am discussing what is hypothesis. Then, what are the different types of hypotheses we are using in a social science research. And after that, I'm discussing about how to test the hypothesis using the SPSS software. Before talking about the hypothesis, I just give an introduction to research. Research is a problem-solving mechanism. So the first duty of a researcher is to identify the research problem properly. So in order to identify the research problem, the researchers can use the existing theories, or the researchers can use the existing studies, or the researchers can use the expert opinion, or even the researcher can use his own expertise for taking the research problem. Then after identifying the research problem properly, the researcher thinks that how to solve that problem. So you can keep in mind, the research is a problem-solving mechanism. First, the researcher identified the research problem, and after the researcher thinks that how to solve that problem. The how to solve that problem lead to the objectives or research questions. So the objectives or research questions are formulated for solving the research problem that are developed by the researcher. So these are some examples of objectives or research questions. The first one is, what container shape is most economical and reliable for shipping a product? What container shape is most economical and reliable for shipping a particular product? And the second one is, which management approach best motivates the employees in the retail industry? Which management approach is best for motivating the employees in the retail industry? And the third one is, what is the most effective means of advertising in a business-to-business model? These are the different research objectives or research questions that are developed by the researcher for solving the identified research problem. So the objectives or the research questions are developed by the researcher for solving the research problem. So in order to solve these kind of research questions or objectives, the researchers are developing some hypotheses. So in order to solve the objectives, the researchers are developing certain hypotheses. So the hypotheses are the statistical form of research questions. The above mentioned are some kind of research questions. So the researchers finally develop some hypotheses. The hypotheses are basically it is a statistical form of questions. These are the above are the research questions. This can be converted into a statistical form of questions. Then only the researcher can able to answer that question using proper statistics. That is the purpose of the hypothesis. So here the hypothesis is a tentative explanation. So once again, the research is a problem-solving mechanism. So in order to solve the problem, problem of the research, the researchers developing certain research objectives or research questions, and based on that, the researchers are developing certain hypotheses. The hypotheses are the statistical form of research questions. Then only the researchers can able to answer that question properly using the exact statistical tool. Then I am moving to the different types of hypotheses we are using in a social science research work. Basically, we are using two different hypotheses in a social science research work. The first one is the research hypothesis, and the second one is the statistical hypothesis. Number of other hypotheses are there, but today I am discussing about the research hypothesis and a statistical hypothesis. What is the interconnection between these two? The research hypothesis and the statistical hypothesis are discussing today. The first one is the research hypothesis. The research hypothesis is a statement. It's a statement of what the researcher believes. It's a statement of what the researcher believes will be the outcome of an experiment or a study. The researcher believes that after conducting the study, this will be the outcome of the study, or this will be the outcome of the particular experiment. So this is the beliefs of the researcher. So the research hypotheses are the beliefs of the researcher. These beliefs are generated by the researcher based on some theories, based on the existing theories that are available to the researcher, or based on the experiences or experiences of the researcher. He can develop this kind of assumption or beliefs, or finally based on the previous work or the present study or the available literature. Based on the available literature, or based on the experience of the researcher, or based on the theories that are available to the researcher makes some kind of research hypothesis, and these are the beliefs of the researcher. This can be true after conducting the analysis. So these are the examples of some research hypotheses. Here the first one is the older workers are more loyal to a company. Here the researcher assumes that, or the researcher believes that, the older workers are more loyal to a company. That means if a worker is an older worker, he is more loyal to a particular company. This is an assumption or the belief that is generated based on the experience of the researcher, or based on the theories that are available to the researcher, or based on the previous work that he can search through the literature review. And the second one is the airline company. The stock prices are positively correlated with the volume of OPEC oil production. If the OPEC company oil production is increasing, this will be positively affected to the stock prices of the airline company. That is another belief or assumption that is formulated by the researcher, again based on the theories, or based on experience, or based on the previous work. That is called the research hypothesis is an important one in social science research. It is a statement of what the researcher believes this will be the outcome of an experiment after conducting the study. Then I am moving to the statistical hypothesis. That is statistical hypothesis. So, in order to scientifically test the research hypothesis, first the researcher develops some research hypothesis based on the theories, experience, or available literature. And after that, in order to scientifically test, or in order to scientifically prove the research hypothesis, a more formal hypothesis structure is needed. So the researcher need a more formal structure of hypothesis is needed by set up with a statistical hypothesis. So the researcher transfer or the researcher convert the research hypothesis into a statistical form of hypothesis. So it is called the statistical hypothesis. So every statistical hypothesis has two parts. So every statistical hypothesis has two parts. The first part is the null hypothesis, and the second part is the alternative hypothesis. So the statistical hypothesis means the researcher convert the research hypothesis into a formal form of hypothesis, that is a statistical hypothesis. Then only the researcher can be able to test that hypothesis using the proper statistics. So the statistical hypothesis consists of two parts, a null hypothesis and an alternative hypothesis. Then I am talking about the difference between the null and the alternative hypothesis we are using in a statistical hypothesis. Then in case of the null hypothesis, there is a null condition exists. There is a null condition exists and exists in the social condition. We are doing in the social science research. So null condition exists in the society, and similarly its alternative is that the logical opposite of the null is the alternative. The logical opposite of the null hypothesis is called the alternative hypothesis. So there is nothing, the null hypothesis believes that there is nothing new happening in the society. There is nothing new happening in the society. This is the beliefs of the null hypothesis. And the alternative is that the new things are happening in the society. Number of new things are happening in the society. Similarly, the old theory is still true. The null hypothesis believes that the old theory are still true, but the alternative believes that number of new theories are there, the new theories are true. They believe that the new theories are true. And again, the old standard is correct. So null hypothesis believes that the old standard is correct, but the alternative believes that there are new standards. There are new standards are there. And similarly, the system is in control. In case of null hypothesis, the system is in control. They believe that the social system at present, it is in control. But the alternative hypothesis, it believes that the system is completely out of control. That is the difference between the null and the alternative hypothesis. This is used for forming the statistical hypothesis. Then I am moving to an example of the null and alternative hypothesis. Here, a wheat flour packaged by a manufacturer. A manufacturer, he focused on packaging the wheat flour, and it is sold by weight. And the size of the package is 1 kg. And the size of each package is 1 kg. And the manufacturer want to test whether their packaging process. In this situation, the manufacturer want to test or manufacturer know whether their packaging process is out of control as determined by the weight of the flour packages. He thinks that the present packaging system is out of control. That is why he wants to test the present situation, whether it is out of control or it is in control. Based on that, the manufacturer developed two sets of hypotheses. The statistical hypothesis. So every statistical hypothesis has two parts. The first part is the null hypothesis. The H0 denotes the null hypothesis. That is, the average weight of a flour package is 1 kg. He thinks that the average weight of the flour package is 1 kg. There is no problem in the present system. There is no problem in the present manufacturing system. The average weight of the flour package is 1 kg. There is no problem. That is the null situation. Based on that, he developed an alternative. The alternative is developed based on his beliefs. He believed that the average weight of the flour package is not 1 kg. The process is in out of control. There is an unusual activity. The process is out of control. The flour is not 1 kg, an average of 1 kg. It may be less than 1 kg or maybe greater than 1 kg that is produced in the manufacturing process. This is an example for the null and alternative situation. Here the null situation says that the average weight of the flour package is 1 kg. Thus, there is no problem in the existing system. At the same time, he developed an alternative. The manufacturer developed an alternative not to know whether the package is proper or not, the system is in control or not. The average weight of a flour package is not 1 kg. The process is out of control. Then this hypothesis can be expressed in a statistical derivation. This is the statistical derivation. Then here the H0 denote the null hypothesis and the H1 denote the alternative hypothesis. And this is the mu value. The mu denote the population mean. Here the mu denote the population mean. Population here, in the case of the wheat flour packaging example, here the mu is the average weight of packages. Mu is the average weight of packages. So in this situation, it is developed as the null is equal to the average weight of, mu is the average weight of packages, that is 1 kg. In the null situation, the manufacturer believes that the system is in control. That is why he developed the hypothesis, the mu equal to 1 kg. That is the average weight of flour packages equal to 1 kg. There is no problem. That is the null hypothesis. So you have to keep in mind, every null hypothesis, every null has 3 alternatives, not one alternative. Every null has 3 alternatives. This is a very basic of the hypothesis. So every null has 3 alternatives. Based on this null hypothesis, the manufacturer developed 3 different forms of alternative. And the first alternative is, here the mu, again the mu is the average weight of the flour packages. He believes that the average weight of the flour package, that is the mu, is greater than 1 kg. The first alternative. Suppose the system is in out of control. Again, the system is in out of control, and the system is manufacturing an above 1 kg packages that lead to loss to the company, and this is a serious issue. Again, this is a serious issue to the manufacturer. And again, he developed another alternative. And another alternative is that, again, the mu represent the average weight of the flour packages. The average weight of the flour package is less than 1 kg. Less than 1 kg. That means the system is again out of control, and it produces a less than 1 kg weight of flour packages. This is another issue. This lead to some legal action, and this also affect the goodwill of the manufacturer. So this is also again a serious problem. Then finally, the manufacturer developed another hypothesis, and this is the last hypothesis he developed. That is, the mu is not equal to 1 kg. He never assumed this is less than 1 kg or it is not less than or greater than 1 kg. He believes that it is not equal to 1 kg. That means whether it is 1 kg or it is less than 1 kg or more than 1 kg, the researcher never give an assumption, and he straight away assumed that the mu is not equal to 1 kg. So the first 2 set of hypothesis is called directional hypothesis. This is direction to one particular area, a left-hand side or the right-hand side of a normal distribution curve. So these first 2 set of hypotheses are called the one-tailed situation, and the last one is called the two-tailed situation. This can expressed in a normal distribution curve. These are the 3 normal distribution curve. The normal distribution curve is a bell-shaped curve. Both the left and right-hand side are equal. And here, in case of the first hypothesis, the positive one-tailed test, we are using an one-tailed test. This hypothesis is solving using an one-tailed test. Similarly, this is using a negative one-tailed test. In both the 2 situations, we are checking either the right or left side of a normal distribution curve. And after checking the normal distribution curve, we take the final decision whether accepting or not. That is the situation. Then finally, this is the mu is not equal to 1 kg. Here, the manufacturer believes that he does not assume whether it is left or right. He believes in between the 2, the middle value. So in this situation, we are checking both the right and left side of a normal distribution curve, and finally, we are taking the decision. That is the case of the wheat flour packaging example. So you have to understand this item, then only you can develop hypothesis. So every null has 3 alternatives. Statistically, every null hypothesis has 3 alternatives. Similarly, I am giving another example. This is another example. Here, I am saying that the male and female are equal with regard to physical standards. This is expressed here. This is a null situation. The male and female are never equal with regard, especially with regard to physical standard. They are never equal. That is why I am developing a null hypothesis. This is the null situation. Here again, the mu represent the population mean, and the m represent the male, and the f represent the female. So the first null hypothesis developed by the researcher is the mu m equal to mu f. The mu m equal to mu f means the population mean of the male is equal to the population mean of female. Suppose based on weight or height or based on any other physical condition. So the researcher developed the male, the population mean of the male is equal to the population mean of the female. That is the first situation. That is a null situation. So I am already said that every null has three alternative. So based on that, the researcher developed three different alternative hypotheses, and this is the first one. Here the researcher write that the mu m, the male, the average mean of the male is greater than female, and the average mean of the male is less than female is another hypothesis, another alternative hypothesis. And finally, the mu m is not equal to mu f, that is the male and female are not equal. That is the three situation we are developing using the hypothesis. The first two are one-tailed situation, and last one is the two-tailed situation. We are checking both the side of a normal distribution curve before taking the final decision. That is the difference between these three hypotheses. So you have to keep in mind every null has, especially in the case of statistical hypothesis, we are using two parts, a null hypothesis part and an alternative hypothesis part. So in case of statistical hypothesis, if we are developing a null situation, it has a possibility of three alternatives. There are three alternatives are there in a null hypothesis. Again, I am going to my third part. Here already I am discussed about what is hypothesis, what are the different types of hypotheses we are using in a social science research work. Here I am talking about only two items. These are very important. The first one is the research hypothesis. Second, I am talking about the statistical hypothesis. The research hypotheses are developed by the researcher based on the existing theories or based on the existing literature or available studies, or based on the expert opinion, or based on the experience of the researcher. The researcher make some assumption, or the researcher believes that this will be true after conducting the study. So it is called the research hypothesis. Based on the research hypothesis, the researcher develops some statistical hypothesis. The statistical hypothesis is a more formalized form of hypothesis. A statistical hypothesis, statistical form of research question. So in case of the statistical hypothesis, there are two parts, a null part and alternative hypothesis. So every null has three alternatives. These are already we have discussed. Then I am moving to my third part, that is the hypothesis testing example using SPSS. Then I am moving to the hypothesis testing example using the SPSS. So you can see, first I am writing an objective. This is an objective of a particular study. The objective is that to identify the most reliable and economical shape of a container for shipping agricultural products. This is an objective developed for solving the identified research problem. The problem is, which is the most reliable and economic shape of a particular container for shipping the agricultural products. Based on the objectives, the researcher developed some research hypothesis. First, the researcher developed some research hypothesis. So the research hypotheses are developed by the researcher. Based on, we already discussed the existing theories, or based on the experience, or based on the available literature, and based on that, the researcher makes some assumption, or these are the three different assumptions based on this objective the researcher made. The first one is all the shape of containers. All the shape of containers are producing different economic benefits from shipping agricultural products. The first one is all the shape of containers are producing different economic benefits. The researcher believes that there are number of shape of containers are there, and all the containers are generating the different economic benefits to the shipping company from shipping agricultural products. This is the first assumption that is developed by the researcher based on the existing theory, or based on the experience, or based on the available literature. Again, the researcher developed another research hypothesis. He developed this that based on the level of operations, in a shipping company, there are two levels of operations are there. One is the selected country oriented operations, and another companies are operating worldwide. So two level of operations are there. The selected country oriented operations and the worldwide operations are there. So based on the level of operation of companies, the economic benefits from shipping agriculture products are varying. They think that the economic benefits from shipping the agriculture products are varying in case of their level of operation. That is similarly developed based on the existing theory, or based on the available literature, or based on the experience of the researcher. Then the third one, the core area of operation. The core area of operations of the shipping company. The core area of operation, there are three core areas are there in a shipping company. Warehousing operations are there, the transporting or supply chain operations are there. So warehousing, transporting or supply chain solutions are there. These are the core area of a shipping company. So the core area of operation have an impact on the economic benefits from shipping agricultural products. So he returned that the research hypothesis he again formulated is that the core area of operation includes a warehousing and transport or supply chain have an impact on the economic benefits from shipping the agricultural products. And these are the research hypotheses that are developed for solving these particular objectives. So the research hypotheses are the beliefs of the researcher. The researcher believes that this will be true after conducting the study. So based on that, he developed three different research hypotheses. And the research hypotheses are again the researcher converted into a statistical form of hypothesis. It is called statistical hypothesis. Again, I am discussing about the statistical hypotheses that are developed by the research. These are the statistical hypotheses. So every statistical hypothesis has three parts. The first hypothesis one, this is the hypothesis one developed by the researcher. This is based on the first research hypothesis. First research hypothesis is the basis of developing the first statistical hypothesis. He developed is that there is no significant difference. There is no significant difference in the shape of containers based economic benefits from shipping agricultural products. He believes that there is no significant difference in the shape of containers. The shape of containers does not lead to any significant difference for the economic benefits from different shipping activity of agricultural products. Again, he developed an alternative. There are significant differences in the shape of containers based economic benefits from shipping agricultural products. One, he thinks that there is no significant difference, and the alternative is that there are significant differences in the shape of container-based economic benefits from shipping the agricultural products. That is the first statistical hypothesis developed by the researcher. Again, he thinks about another statistical hypothesis based on the second research hypothesis, that is both the level of, there are two level of operations are there, selected country and worldwide country operations are there. So both the level of operating companies are having similar economic benefits. Both the level of operating companies, there are two level of operating companies are there. The selector country oriented shipping companies are there, and the worldwide operating shipping companies are there. And they think that both the level of operating companies are having a similar economic benefits from shipping agriculture product. They think that both the companies are having a similar economic benefits from shipping the agricultural products. Based on this null hypothesis, the researcher developed an alternative is that both the level of operating companies are having the different economic benefits from shipping agricultural products. So this way, the researcher developed the second on the second research hypothesis, and finally he developed another hypothesis, statistical hypothesis, that is here the core area of operation. There are three core areas are there: the warehousing, transport, or supply chain solution. It does not affect the shape of containers, does not affect the core area of operations, does not affect the shape of containers for shipping agricultural products. Here the researcher believes that the core area of operations, it does not affect the shape of containers for shipping agricultural products. Similarly, he developed an alternative. The alternative is that the core area of operations, affect the shape of containers for shipping agricultural product. They believe that the core area of operations affect the shape of containers for shipping the agricultural products. These are the three different statistical hypotheses developed by the researcher. So the first one is the objective. The objective is developed for solving the identified research problem. Here the research problem is which is the most economical and which is the most reliable and economical shape of a container for shipping the agricultural product. Based on that, the researcher developed some research hypotheses. The research hypotheses are the beliefs of the researcher. This can be developed by the researcher based on the existing theories, or based on the existing available literature or existing literature, or based on the expert opinion, or based on the experience of the researcher. Based on that, the researcher developed three different research hypotheses. And based on this research hypothesis, the researcher again developed some statistical hypotheses. The statistical hypotheses are the statistical form of research questions. So, and every statistical hypothesis has two parts. The first part is the null hypothesis, and the second part is an alternative hypothesis. And based on the research hypothesis, in order to solve this research hypothesis, the researcher developed three different statistical hypotheses. Then I am moving to how to solve these three hypotheses. These three hypotheses are developed by the shipping company officials for solving their problem, or developed by the researcher. So in order to solve these three hypotheses, the researcher developed an interview schedule. This is a sample interview schedule developed by the researcher. First is the title of the study: a study on the identification of label and economical shape of containers for shipping agricultural products. This is an interview schedule focused on the shipping company officials. This interview schedule is for the shipping company officials, and the interview schedule is divided into two parts. First part is the sampling details, and the second part is the core area, that is the objective of the study, that is the identification of label and economical shape of a container. That is the objective of the study. So based on that, the first item is the serial number of the questionnaire, and the 1.2 is the level of operation. There are two level of operations are there in a shipping company: the selected country oriented operations and the worldwide operations are there. And based on that, the level of operation, first they are measuring the level of operation. And the second question is the core area of operation. There are three core areas are there: the warehousing are there, the transporting or supply chain solutions are there. Then these two questions are the nominal variables for collecting the data. And the second major question is identification of reliable and economical shape of a container. So in order to identify the reliable and economic shape of a container, first the researcher identified what are the different shape of containers available in a shipping company. These are the 4 different shape of containers available. The first one is the 20 feet general containers are there, and second one is 20 feet high cube containers are there, and the third one is 40 feet general containers are there, and last one the 40 feet high cube containers are there. These are the different shape of containers that are available in a shipping company. So based on that, he developed a question. The question or a statement. This is an interview schedule. He developed a statement is that please state your opinion for the identification of most reliable and economical shape of a container for shipping agricultural products. And the data is collected in a 5-point scale. And the scale is that the 5 is for most reliable and economical, and the 4 is for the reliable and economical, and 3 is given for the moderately reliable and economical, and 2 is for not reliable, and 1 is highly not reliable. Based on this question in the statement, he given a 5-point scale. Based on the 5-point scale, the researcher collected the data from the shipping officials. About 400 sample respondent is collected for the study, and the data is entered in a Excel sheet. This is a sample Excel sheet for data entry. These are the serial number of the questionnaire, and 1.2 and 1.3 are the question number 1.2, the level of operations, and 1.3 is the core area of operations, and question number 2.1, 2.3, and up to 2.4 are the different shape of containers. These are the different shape of containers, and after entering the data in this form of Excel entry sheet, he transferred the data into the SPSS software for conducting the final analysis. So then I am moving to how to solve each hypothesis we are formulated for the shipping company related problem. And first I am talking about how to test the first hypothesis. This is the first hypothesis. There is no significant difference in the shape of container based economic benefits from shipping agricultural products. And its alternative belief that there are significant differences. There is no significant difference, and there are significant difference. Based on that, this hypothesis, the researcher developed a statistical tool, or the researcher fixed a statistical tool, and here the researcher select a statistical tool, and the tool is that one sample t-test. One sample t-test is used for testing the hypothesis, and after moving the Excel entry, the data into the SPSS data set, he move on to compare mean. Then he take the position on sample t-test. So go to analyze, compare mean, and he select the one sample t-test. After selecting the one sample t-test, he got a pop-up window. This is the pop-up window that is generated by the SPSS. These are the different variables, and he moved the 4 different shape of containers into test variable and given a test value 3. This I can explain later. He gave a test value 3, and finally he click OK. Only 2 procedure. Go to analyze, compare mean, and one sample t-test is a procedure of using testing the one sample t-test. In SPSS, he got another pop-up window. This is the pop-up window, and in this window we can move on which variables are used for testing. Here we are testing the 4 different shape of containers. For these 4 different shape of containers are move on to the test variables, and finally giving the test value. This I am explain later. Giving a test value 3, and finally click OK. He got an output in SPSS output window. This is the output generated by the SPSS. This is the output. There are 2 tables are there, and one sample statistic table and one sample test values are there. In this table, some values are we are used for the reporting purpose. Here these are the variable name, and number represent the number of sample size. Here 400 sample size are selected for the study, and here this is a mean value, and this is the standard deviation value. And here from this table we are choosing only two items. That is the first one, the t-score. This is a t-score value, and this is the significant level or the p-value. This one sample t-test is a two-tailed test. Both the tail are checking the normal distribution curve. Both the tail are checking by the one sample t-test. So the significant, this is a p-value, that is a significant value. Based on that, the researcher developed a table is created for the final reporting, and this is the table created by the researcher for the final reporting. Here the first column represents the variable column, that is the different shape of containers, and second column is for the mean value, and the third column is for the standard deviation and t value, and finally the p value. And here and in this test, in the on-sample t-test, first you have to understand on-sample t-test is a parametric test. It is a parametric test, and the on-sample t-test is used for a comparison purpose. The comparison is done by using the mean value. The comparison is done by using the mean value. Here, in case of 20 feet general shape of containers, there is only one mean value. The mean value is 3.465 is the mean value. This is the sample mean value. We are collected 400 sample respondents in a 5-point scale. Based on a 400 sample respondent, we got a mean value 3.465, a sample mean value. We are comparing this sample mean value with the hypothesized population mean, because the population mean is unknown. Here we cannot know what is the exact population mean. In this situation, the researcher assumed that it is otherwise known as assumed mean, or it is otherwise a hypothesized population mean. Here the researcher assumed a particular mean value for testing or for comparing the sample mean value, and the researcher assumed that that is the exact position. So in a 5-point scale, the middle value, that is a 3, is the moderate value. 3 is the moderate value or the middle value, and the researcher assumed that the 3 is the moderate value and the 3 is the population mean, assumed mean. So we are giving the test value 3 in this analysis. We are giving the test value 3. So the test value means here the researcher assumed that this is the population mean, because we are using a 5-point scale. In between the 5-point scale, the researcher never take a position to a deviated position. The researcher take an unbiased position, and researcher believes that 3 is the moderate position, 3 is the population mean. This is the assumed mean. The researcher assumed this is the population mean, that is the test value 3, and giving the test value 3. And the one sample t-test compare this sample mean with the hypothesized population mean. Here the hypothesized population mean is 3, and we are comparing the 3 with the 3.465. So the one sample t-test compare the test value 3 with this average mean, sample mean, this sample mean 3.465, and we got a result. And the p-value is the decision-making variable. Here the p-value, this is a standard deviation value, and the p-value is the decision-making variable. So here the p-value is the decision-making variable, and if the p-value, the rule is that if the p-value, that is here, if the p-value is less than 0.05, if the p-value is less than 0.05, there is a significant difference between the average mean or hypothesized population mean and the sample mean. That is the inference. If the p-value is less than 0.05, there is a significant difference between the average mean or hypothesized population mean, that is a 3, The 3 and 3.465 is significantly differed. And if the p-value is greater than 0.05, there is no significant difference. There is no significant difference between the hypothesized population mean and the sample mean. That is the decision-making technique in on-sample t-test. So again, I am saying that on-sample t-test is a parametric test. The on-sample t-test is used for comparing the sample mean and the hypothesized population mean. In a 5-point scale, we are using the hypothesized population mean is that 3 is the hypothesized population mean, that is the moderate value. Then after comparing the 3 with the actual mean, this is the sample mean, actual mean, we got there is a significant difference or not, that is tested by using the t-test, and this can be interpreted using the p-value. If the p-value is less than 0.05, there is a significant difference between the average mean and sample mean. If the p-value is greater than 0.05, there is no significant difference between the average mean and the sample mean. Here, again the t-value, we got a t-value. There is no interpretation. We are returning the thesis about the t-value, but the t-value represent, if we got a large t-value, the deviation is very high. The deviation between the sample mean and the hypothesized population mean is very high. Or if the mean value is less, if the t-value is comparatively less, this means the deviation is very minimum. If we are checking this third item, the 40-feet general type of containers, we got a mean value 2.95. 2.95, it is about equal to the 3 value. After comparing the 2.95 with 3, we got a p-value. The p-value is insignificant p-value. The p-value is greater than 0.05. That means there is no significant difference. There is a difference is there, 0.5 difference is there, but the p-value says that there is no significant difference between the 3 and 2.95. There is no significant difference, and you can see that here the t-value is minimum. T-value is a very low t-value. That means there is the deviation is very low. Deviation is very low. Then again there is an inference is there. We can see that again we can able to write some inference based on the mean value, the descriptive statistics. That is writing inference based on the scale. We are giving a 5-point scale. That is the mean value. If the mean value ranges between 0 and 1, if the mean value ranges between the 0 and 1, it is highly not reliable. If the mean value ranges between 1 and 2, if the mean value ranges between 1 and 2, this is a situation of a not reliable situation. And if the mean value ranges between 2 and 3, it is a moderately reliable and economical situation. And if the mean value ranges between 3 and 4, reliable and economical situation. And if the mean value ranges between 4 and 5, most reliable and economical situation. So based on that, we can move on with the mean value. Here, the first mean value is ranges between 3 and 4, 3.465. And the second one is also ranges between the 3.365, that is ranges between 3 and 4. And the last one is also ranges between 3 and 4. That means we take in the position 3 and 4, reliable and economical. So all these 3 shape of containers, if we are using these 3 shape of containers, the shipping company can make a reliable and economical income from using this 3 item. But in the case of the third containers, they are more using the third containers. The third item, that is this ranges between 2 and 3, that is moderately reliable and economical. This is only a moderately reliable and economical. And from among these, the highest mean values value in the case of 20-feet general containers. That is, if you are using the 20-feet general containers, the shipping company can make a more profit. That is, they are making more profit because 3.465 economical and reliable is there. That is the inferences we are developing using the one sample t-test. Based on that, there are three significant items and only one item is insignificant. So based on the majority of the item, the researcher take a decision, failed to accept the null hypothesis. He take a decision, failed to accept the null hypothesis, and the null hypothesis is that, you can see the null hypothesis. This is the null hypothesis. There is no significant difference, but there are 4 different types of containers are there. After analyzing the 4 different types of containers, 3 of them shows a significant difference. All are giving a positive difference. All are giving a positive difference, that is reliable and economical. That is why the researcher failed to accept the null hypothesis. That means the researcher reject the null hypothesis. There is no significant difference in the shape of container based the economic benefits from shipping agricultural product. And finally, the researcher take the decision. There are significant differences in the shape of containers based the economic benefits from shipping agricultural products. That is the testing of the first hypothesis. I think all of them understand the concept. Then I am moving to the second hypothesis. This is the second hypothesis, testing of the second hypothesis. This is the hypothesis is that both the level of operating companies are having similar economic benefits. Both the level of operating companies are having a similar economic benefits from shipping agricultural products. And the alternative is that both the level of operating companies, there are 2 levels of operations of shipping companies are there. Selected country oriented shipping companies are there, and worldwide operating shipping companies are there. So both the level of operating companies are having a different economic benefits from shipping the agricultural products. Based on this hypothesis, the researcher want to compare the selected country oriented and worldwide oriented shipping companies. So in order to compare these 2 companies, the researcher select an independent sample t-test. The independent sample t-test is again a comparative test for comparing 2 means. This is a parametric test. Independent sample t-test is again a parametric test. This is used for comparing the 2 means. Here there are 2 means are there. The selected country and worldwide operating companies are there. Both are having 2 different mean values. So in order to compare these 2 mean value for taking the decision in this regard, in this hypothesis, so the researcher take a decision to choose the hypothesis, choose the test. Here the researcher take a test, independent sample t-test is used to test the hypothesis. This is this is a procedure similar to the one sample t-test. He again move on to analyze, compare mean. He select the independent sample t-test. He move on to analyze, compare mean, select the independent sample t-test. After selecting independent sample t-test, he got a pop-up window. This is the pop-up window. Here, similar to the one sample t-test, the researcher moved the different variables. There are 4 different variables are there. 4 variables means a different shape of containers are there. All the 4 different shape of containers are move on to the test value or test variables. And the grouping variable. Grouping variable means which variable is used for the comparison purpose. Here the selected country and worldwide operating companies are for we are comparing. So select that nominal variable, that is the level of operation. We are move on to, that is the question number 1.2, level of operation. The level of operation is we move on to the grouping variable. We are moving to the grouping variable, and finally we click OK. We got this kind of an SPSS output. This is an SPSS output generated, and here also 2 different output tables are there. In the first table, you can see that the first column is the different shape of containers or the name of the variable. And the second one is the level of operation. There are two level of operations are there. The selected country oriented companies are there, and the worldwide operating companies are there. And this is the number of sample size from each category, and this is the mean value and standard deviation value. And this is the independent sample t-test. Here we are taking only two columns for final reporting. We are choosing this t value. We are choosing this t value, and this is a significance value or p value. Choosing this t and this p value only. And after choosing this, the researcher make a table for reporting. This is the reporting table created by the researcher. Here, the first column is again the variable, that is the different shape of containers used in a shipping company. And this is the level of operation. There are two level of operations are there. These are the two level of operation we want to compare for checking the hypothesis. The one is the selected country oriented, and another one is the worldwide operating companies. So the selected country oriented companies are again classified into the mean and standard deviation column. Is again one is how a mean value and a standard deviation value, and we got again a t value and a p value. So and finally the decision is based on the p value, similar to the one sample t test. The decision we are taking based on the p value. If the p value is less than 0.05, if the p value is less than 0.05, there is a significant difference between the worldwide operating companies and the selected country oriented companies for choosing the different shape of containers. Again, if the p value is greater than 0.05, there is no significant difference between these worldwide operating companies and the selected country oriented companies for choosing the different shape of containers. So based on that, we are taking the decision. Here all the p values are greater than 0.05. All the p values are greater than 0.05. There is no significant difference in choosing all the different shape of containers. There is no significant difference in the level of operations of shipping company. That is an inference from this table. Again, the independent sample t-test is a parametric test. The independent sample t-test is used by the researcher for comparing two means. Here the researcher want to compare the selected country and worldwide operating companies for testing the hypothesis. That is why the researcher select the independent sample t-test for checking the hypothesis. And after selecting the hypothesis, the researcher conduct the analysis, and finally he got the result, and he interpreted the result based on p value. If the p value is greater than 0.05 in all this situation, that is means there is no significant difference in the level of operation if a company is operating in a selected country or if a company is operating worldwide. There is no significant difference between these two companies. That is why the researcher finally take a decision to accept or reject the hypothesis. Here the researcher take a decision, fail to reject the null hypothesis. That means the researcher accept the null. We can check on that. This is the second hypothesis. Both the level of operating companies are having similar economic benefits from shipping agricultural products. That means both the selected country oriented and the worldwide oriented companies are there. If we are comparing with the two, we can understand that both are having a similar economic benefits from using the different shape of containers for shipping the different agricultural products. There is no significant difference between them. That is why the researcher accept the null hypothesis and reject the alternative. This way the researcher take the decision, and then I am moving to the last hypothesis, the testing of the last hypothesis, that is the third one. This is the third hypothesis. The null is the core area of operations. The core area of operations, there are three level of operations are there. The warehousing, transporting or supply chain solutions are there. It does not affect the shape of containers for shipping the agricultural products. The researchers already given the alternative, the core area of operation. It affects the shape of containers. So the area of core area of operation does not affect the shape of containers for shipping agricultural products. Again, he believes that it affects the shape of containers for shipping the agricultural products. Based on that, he want to compare the warehousing core area operated companies and the transport oriented companies. There are three core area of operations in a shipping company. The warehousing oriented companies are there, the transporting oriented companies are there, then the supply chain oriented companies are there. Here the researcher want to compare the warehouse oriented shipping companies and the transport oriented shipping companies, and finally the supply chain solutions oriented shipping companies. These are the three different core area of operation. The researcher want to compare these three different core area of operating companies for checking the hypothesis. In this situation, the researcher want to compare three mean values. So in order to compare three mean value, more than two mean value, that is three mean values there for comparing. That is why the researchers select a statistical tool, one-way ANOVA. Here the researchers select the statistical tool, one-way ANOVA. Again, the one-way ANOVA is a parametric test. In the one-way ANOVA is a parametric test. This parametric test is again used for the comparative purpose. Here the researcher want to compare the warehousing oriented companies and the transporting oriented companies, and also the supply chain oriented companies are there. We want to compare the mean value, at least three mean values there. Then based on that, the researcher again move on to click analyze, select compare mean, and finally he select the one-way ANOVA. The similar procedures in the above two hypotheses. We move on to analyze, compare mean, select the one-way ANOVA. Then based on that, the researcher got a pop-up window. This is a pop-up window generated by the SPSS, and here these are the different variable listing column, and he move on the four different shape of containers. Here these are the four different shape of containers are move on to the dependent list, and finally he select the factor for comparison, the nominal variable. Here the factor for comparison is the core area of operation. He move on to the core area of operation with the factor column, and finally he click OK. He got a result. This is the result generated by the SPSS. There are two tables are there. This is the first table, and this one is the second table, and again this is the variable column, and this is the core area of operation. Warehousing, transport, supply chain solutions are there. This is the mean value, and this is a standard deviation value. This mean value and standard deviation values are taken by the researcher for the final reporting, and this is the ANOVA table. Here we can go an F value and a significant value or P value. Here this mean value and this standard deviation value and this F and the significant values are taken by the researcher for the final reporting, and after that the researcher developed a table. This is the table developed by the researcher for final reporting. Here this is a variable column. This is a variable, again variable. These are the different shape of containers. This is the core area of operation. There are three core area of operations are there. Warehousing are there, transporting oriented companies are there, the supply chain oriented companies are there. Then this is again each area of operations are mean value and standard deviation, and there is an F value, a distribution, and a P value. And again the decision is based on P value. Similar to above, the decision is based on P value. If the P value is less than 0.05, there is a significant difference between these three items, these three core area of operations. If the p-value is greater than 0.05, there is no significant difference between these three core area operations. Here we can see that all the mean p-values, all the p-value are greater than 0.05. That means in case of using all the different shape of containers, why? Based on the core area of operations, there is no significant difference in all these three core area operating companies. There is no difference is there. Based on that, the researcher failed to reject the null hypothesis because he accepting the null hypothesis. The null hypothesis is that the core area of operation, there are three core area: warehousing, transporting, or supply chain solution. It does not affect the shape of containers for shipping agricultural product. And finally, the researcher accept the null and reject the alternative hypothesis. This is the situation. So my presentation is over. Then I hand over to Dr. Ajesh. Hello.
Thank you, Dr. Amal Kumar, for the nice presentation. Now I invite participants to take part in the discussion. Clarify the doubts. Any participants, please come forward and ask your doubts. You can unmute your mic. Participants, please ask your doubts, clarifications.
Hello, sir.
Okay.
Sir, myself Sharon Thomas. I'm a research scholar in St. Joseph College, Tamil Nadu.
The voice is not clear.
Sharon Thomas, you can speak.
Okay, sir. Can you explain in a similar manner what is? Okay, I'll come in, sir.
Hello.
Hello, I cannot be able to hear properly.
You can speak now.
I cannot able to hear the question properly.
So
hello,
Sharon
sir.
Thomas asked a doubt regarding the determination of significant difference means.
Hello, sir.
What's the question?
What
Yes,
is the question?
what do you mean by significant difference? That's the question.
Hello.
Okay.
What do you mean by significant difference? Significant difference means there are differences are there. We are choosing.
Hello.
Hello. I am audible. Hello.
Yes, sir. You are audible.
Yes,
Okay. We are doing research at a 95% confidence level, and again the 5% is an error term. Based on that, we are selecting. We are choosing the significance level 0.05, and if we got in the case of we are discussed the three different statistical tools. Based on these three different statistical tools, if the p-value is less than 0.05, there is a difference. Difference means there is a significant difference. That means there is an elaborate difference. If we got a mean value 2.95 and we are comparing the 2.95 with 3, there is a difference is there. There's difference is 0.05 difference is there, but the difference is not so significant. Only a minute difference is there. The reason is that we never take 100% accuracy. We are taking the 95% accuracy in social science research. That is the reason for selecting this kind of a significant level. Okay.
Thank you, sir.
The next question.
Good morning, sir.
Good morning.
So can you please explain when to use which test? When to use simple regression, this t-test, multiple regression, NV, ANOVA? When to use which test?
First of all, we have to understand the use of a different statistical tool is very important for choosing a statistical tool. That is very important. So I am, first of all, the regression test is used for predicting something. We want to predict something. We have 3 or 4 variables are there. Based on that 3 or 4 variables, we want to predict some another variable. In this situation, we are using the regression. And today we are discussed only 3 different statistical tools. These are the basic tool. The reason is that all are not familiar with the different statistical tool. Here we are chosen based on the nature of the hypothesis. In case of the first hypothesis, we are selected the one sample t-test. The reason is that there is not find the significant difference between the average mean and the population mean. The reason is like that. What is the purpose of the particular hypothesis? Here the purpose is to compare the average mean and the hypothesized population mean. That is the 3 and the sample mean. 3 is the test value, or 3 is the assumed mean given by the researcher, or 3 is the population mean. The researcher believes that this is the population mean, and the researcher assumed that. Based on that, in order to compare the 3 with actual mean, the actual mean is the sample mean generated based on the 400 sample collected by the researcher. So he want to compare that to mean. So he selected test. Here the researcher select an on-sample t-test is a parametric test. It's opposite. Non-parametric keys are available. Number of another tests are available, but the researcher his ability to use the one-sample t-test, he select that particular tool. A parametric tool is selected for testing the hypothesis. But in the case of the second hypothesis, he want to compare the level of operating companies. He want to compare the level of operating companies. There are 2 levels of operating companies are there. The one is the single country oriented companies, and another one is the worldwide operating companies are there. So, and that hypothesis, the researcher want to compare that 2 companies. That 2 companies he want to compare. So, in order to compare that 2 companies, he select again a comparative test. Here, independent sample t-test, the purpose of the independent sample t-test is to compare 2 means. That is the purpose of independent sample t-test. So he know the purpose of the independent sample t-test. So he choose the independent sample t-test is apt for comparing the single country oriented company and the worldwide oriented companies. That is the purpose of selecting the second hypothesis, second test in the second hypothesis. And in the case of the third one, again he want to compare. The hypothesis mainly focused on comparison. The comparison is that you want to compare the core area of operations. There are 3 core area of operations in that hypothesis. 3 core area of operations are there. The first one is there someone are focused on the warehousing, or someone are focused on transporting, and someone are focused on the supply chain solution. So these are the 3 different companies, core area operating companies are there. At that hypothesis, the researcher want to take a decision only based on comparing these 3 different companies. So in order to compare these 3 different companies, again the researcher select a comparative test. He know ANOVA is a comparative test. It is used for comparing 2 or more mean values. So he based on the ANOVA rule, he can find that this test is suitable here, and he choose the ANOVA for testing that situation, and based on that he compare these 3 mean value, and finally he take the decision. And this is hypothesis testing is very difficult if you understand the only a preliminary basic knowledge, but you have to know about more testing tool. Then only we can able to apply the proper statistical tool. Again, I am saying that Every statistical tool has a hypothesis. Every statistical tool. So you have to understand first which statistical hypothesis is there in every hypothesis. What are the hypotheses are developed for each test? You have to understand that this is easy for selecting the tool for a particular study. I think I am okay with the answer.
Sir, one more question. Can you please explain this one tail and two tail?
Okay. We are developing, every null has three alternative hypotheses. Every null has three alternatives. The first alternative is, if you, in case of this example, I'm moving to that example. Here, in case of, this is an example we are developed. Here I am saying, the mu is the average weight of the wheat flour. Mu is the average weight of the wheat flour. And the researcher thinks that the average weight of the wheat flour is equal to 1 kg. The average weight of the wheat flour is equal to 1 kg. The system is in control. There is no issue in the particular system. That is the null situation. It is a null situation. But the researcher again believes that these beliefs are generated, these three different beliefs are generated based on his expertise or based on the theories or based on the previous studies. And he knows that based on the experience, he thinks that the mu is greater than 1 kg. That means the system is again out of control. The system is out of control and the system is producing a greater than 1 kg products, 1 kg flour packages. Again, he believes that the system is again out of control. It produces less than 1 kg products. Less than 1 kg products. That means if the system is again out of control, the average weight of the flour package is less than 1 kg. And finally, he thinks that he does not know it is greater than position or a less than position. That is why he thinks that in between the two, the mu, that is the average weight of the flour package, is not equal to 1 kg. These are the three different alternatives. The first two alternatives are one-tailed situation. The tail means the two left and right hand side of a normal distribution curve. This is a normal distribution curve. Each normal distribution curve has two tails. This is the first tail and this is the second tail, or the right or left are two different tails. Based on this hypothesis, the researcher checked this is a positive tail. The right hand side is a positive tail and the left hand side is a negative tail. And based on this first alternative, the researcher checked whether the manufacturing process produce more than 1 kg or not. If producing more than 1 kg, he accepts the hypothesis. If not producing more than 1 kg, he rejects the hypothesis. That is the use of one-tailed situation. This is the one-tailed situation. Similarly, he can use again the system is producing less than 1 kg. Based on, he again check the negative side of a one-tailed test, or the left-hand side of a normal distribution curve, and he again choose the decision whether he check only the left-hand side, whether it is negative or not. Whether it is negative or not. After he checking whether it is negative, he accept the null. It is not negative, he reject the null. That is a situation. He reject the alternative. That is a situation. And finally, he check both the tail of a normal distribution curve. Both the tail. That is a situation of hypothesis. Last hypothesis. That is, the mu is not equal to 1. He never assumed it is greater than position or it is a less than position. The system is producing a more than 1 kg or system is producing more than less than 1 kg. So he checked both the tail of a normal distribution curve. That is the tailness of a hypothesis. The left hand side or right hand side is chosen based on this hypothesis. Okay.
Thank you so much, sir.
Hello? Hello?
Participants, do you have any more questions? Thank you all.